Okay, pressure and gravity. 21. What are the three effects that contribute to the pressure in all fluids, and what is the fourth effect that contributes to the pressure only in liquids? Okay, so in all fluids it's going to be gravity, which we covered. It's going to be the motion of the fluids, and then it's also going to be the surface effects, which we didn't cover in this course. Surface effects. But make sure from the course coordinator, because I do see that you need to, there is the self-study part, but just make sure from the course coordinator whether you need to cover these. It's 18.4 and 18.8. But we looked at the gravity effects of pressure and the motion effects on pressure. So these three, actually hold on, let me just include all of them. I see I've actually made a slight mistake. And then the fourth one, there are four effects. The fourth one is collisions, the collisions of particles. Okay, so this is 21. The collisions of particles. Okay, so there's these four effects: gravity, motion, surface effects, okay, and collisions of the particles. Gravity, motion, and collision, these three affect all fluids, and the surface effects only affect liquids. Okay. Only affects the pressure in liquids. 22. Approximately what? Now, okay, you can do this one on your own. 23. What is hydrostatic pressure and how does it vary in a liquid at rest? Hydrostatic pressure is simply the pressure that is due to gravity. It results from the gravitational force. The deeper you go, the higher the pressure, and it decreases linearly with height, and it increases linearly with depth. Okay, well, that's the same thing I'm saying in a liquid. Okay. 24. How does an object's average mass density determine whether the object floats, sinks, or hangs motionless? Okay, well, if the average mass density of the object is smaller than the mass density of the fluid, it floats. If the average mass density of the object is larger than the fluid, it sinks, and if they're the same, then it hangs motionless when placed in the fluid. Okay. 18.6. What is gauge pressure and what is the relationship to atmospheric pressure? Gauge pressure is simply the pressure in excess of atmospheric pressure. So if you've got a device and you measure a gauge pressure of say 1 kilopascal, then the actual total pressure is, you need to add atmospheric pressure, right? So you need to add 1 atmosphere. So that the actual pressure is what you read, the reading that you get, plus the atmospheric pressure. That's the total pressure. So gauge pressure is just the pressure in excess, in addition to the atmospheric pressure. Describe 26. Describe the main components of a hydraulic system and how the system can multiply a force magnitude. Okay, so the basic idea is you've got a system and it's filled with a fluid. Okay, filled with a fluid. Okay, and you have a piston here. And you have a piston, oh dear, I just erased everything. You have a piston there, okay? So you can apply a force down and the pressure will apply a force up, okay? Now, the benefits of this is that as you apply a force down, it increases the pressure, and that pressure gets distributed evenly throughout the fluid. So the pressure change is the same. And so if we've got the pressure over here, P1, and we've got the pressure there, P2, the pressure P1 is equal to F1 over A1, and the pressure P2 is F2 over A2. So and you need to go and look at the derivation and the description in this section, okay? I really encourage you need to make sure that you go and understand it. The assumption is that P1, because of the density of the fluid and because the heights are not that dissimilar or not that different, the assumption is that P1 is approximately equal to P2. So F1 over A1 equals F2 over A2. So F2, the force that you're applying over here to push the piston up, is equal to A2 over A1 times F1. So if A2 is larger, then you are essentially multiplying F1 by this factor of A1 over A2. So that is how a system can multiply a force magnitude.